Oh yeah, so we, to answer our research questions, the research question was, are interactions with faculty the most important type of involvement for students? Well, pretty much evidence from this sample suggests that it's not. If we look at efforts with faculty, it is not statistically related with general education gains. So the hypothesis we made at the beginning of the studies is not supported. So that's basically then the how you would conduct and interpret a standard multiple regression analysis. You could also use this coefficients table to get, this is where your regression, if you want to write out the regression equation, you would get them from these unstandardized coefficients. So this would be your y-intercept or your constant. So the regression equation would basically be general education gains equals 0.436 plus 0.14 times total units taken minus 0.024 grades plus 0.031 course learning, yada, yada, yada. You can see that in the write-up here. Wrote out the equation for you there. So for the block entry regression, we'll run this analysis basically the same way. We're going to analyze regression linear. I'm going to actually reset all of this so we can start from scratch. We'll bring our dependent variable over to the dependent column. And then we're going to bring our first set of independent variables over to the independent column. So in the first block, we were going to enter the total credit hours taken and grades. We enter those into the first block. And then we're going to click this next button to put in our next block. Our next block, we want to put in our main independent variable of interest, quality of effort with faculty, move it over, and say next. Then we want our third block, block 3 of 3, which was all the remaining items, which was coursework, library, student acquaintances, and writing. We click on statistics again. We need to check this time on definitely this R-squared change statistic. We could also get descriptives, part and partial correlations, and collinearity diagnostics if you want those. We're going to get our partial correlations this time, talk about those a little. We'll click OK. So the first thing that comes up is this variables entered, removed table. And so this is good just to check to make sure you entered the variables in the correct order you wanted. So in block 1 or model 1 with SPSS concept, we have grades and credit hours. That's what we wanted. In block 2, we have quality of effort with faculty. That's what we wanted. And in block 3, we have library activities, student acquaintances, writing activities, and course learning. So it's a good way to just check to make sure we have the correct variables in the model. You'll notice your model summary is a little bit different. We now have a model summary for each one of our blocks. So we'll start talking about this. So the first line is the model summary for the first block, where we entered just grades and credit hours. So the R-squared here is saying that the linear combination of grades and credit hours is explaining 13.1% of the variation in general education gains. Similar thing for the R-squared. The rest of the R-squared change, after you can kind of ignore the rest of this. This R-squared change is the same as R-squared because there's no change in the R-square. Same thing with this F change, it's the same as the F in this ANOVA model. The second line is saying, okay, now that we've added quality of effort with faculty, how does that change the model? So it's saying this R-squared now is saying that the linear combination of grades, credit hours taken and quality of effort with faculty are explaining 20.8% of the variance in general education gains. The R-squared change is really just the difference between this and this. So it's saying, so what this is saying is that the addition of quality of effort with faculty is explaining an additional 7.7% of the variation in general education gains. This F change statistic is saying that this is a significant proportion of variance explained. So it's basically saying that quality of effort with faculty is important in explaining variation in general education gains. Model 3 here. So now notice this R-squared is the same R-squared we found in the last model because the two models are the same in this case. The two models are congruent. So this is saying that, you know, the linear combination of independent variables, so that's grades, total credit hours taken, quality of effort with faculty, quality of effort in library, quality of effort with students, quality of effort in writing, quality of effort in coursework, are all explaining 39.2% of the variation in general education gains. This was the same adjusted R-square we found before. What's new is this R-square change, which is just the difference between the R-square at Model 2 and Model 3. And it's saying that the addition of all of those other quality of effort variables are explaining an additional 18.4% of the variation in general education gains. This F change test is saying that this is a statistically significant proportion of variance, explain that this 18.4% of variation is statistically different than 0. You have a summary ANOVA table again for each block. The third block will be the same summary ANOVA table as we found in the standard regression analysis because they're the same model here. So they can all be interpreted in the same way as before. You'll notice your coefficient table is a lot larger this time because now we have coefficient estimates at each block. And what's nice about a block entry regression is we can see how the impact of a variable on the outcome changes when you start controlling for other variables. How does the relationship between that variable and the dependent variable evolve once you've started statistically controlling for other variables? So we see in the first block that total credit hours is significantly related with general education gains, and grades are not. When we add in quality of effort with faculty, we see that total credit hours is still significantly related with general education gains, and the effect of it has gone down a little bit. You can also see as the standardized effect has gone down a little bit. Grades is still not significantly related to general education gains, but quality of effort with faculty is. So it's saying that the more time and effort students put into their interactions and involvement with faculty, both inside and outside the classroom, leads to greater growth and development in college. But watch what happens when we start controlling for these other quality of effort variables. So then in our third block, we see total units taken, so total credit hours taken is significantly related with gains. Notice this block, all your coefficient estimates are all then the same that we found in the standard regression analysis. We see grades is not related, and look, quality of effort with faculty isn't related with general education gains. This was the same thing that we found in the standard regression analysis. And so this is basically saying that, you know, once we've once we've controlled for all, once we've kind of taken into account, you know, students' efforts on all of these other activities, that the quality of effort with faculty isn't as important in explaining variation in general education gains. What's happening here in number 2 is we've left out some other important predictor variables of general education gains. And so a lot of that's then being picked up by some of those omitted covariates are being picked up by this quality of effort with faculty. So we're getting sort of a false inflation of the effect of that variable. You can see is once we've started controlling for these different quality of effort, you know, really it's all the academic involvement variables that the theory was talking about, you know, course learning, library use, writing activities were the most important in explaining general education gains. The 2 social involvement variables, the quality of effort with faculty and the effort with students, with other students, are both not statistically significant. So it's really the academic involvement, at least for what this sample is suggesting, that's most important for students' growth and development. The last table you can kind of ignore here. This is excluded variable. So it basically says, well, what would happen in block 1 if I add in quality of effort with faculty? Well, that's essentially giving us the same results we would get in model 2. Notice it's the beta weight, so the standardized coefficient would be 0.286, and that's what we have here. So what this is saying is, well, if you added quality of effort with faculty into model 1, this would be the standardized regression weight. This would be the T statistic. This would be the sig level. Same thing here too. Ooh, if you add in quality of effort with writing in the first model, this would be its beta weight. So you'll get those for the 2 models. I didn't include all of the variables in the analysis. One thing different that I asked for here, I forgot to talk about, you asked for the additional correlations. So basically the 0 order correlation, this column, this is just your regular old standard Pearson bivariate correlation. So if we were to just run a correlation on units total and general education gains, you'll get 0.360. That's what you get here. The partial correlation, what this is saying is this would be the correlation between credit hours and general education gains after you have statistically controlled for or parceled out the effects of the other independent variables. So once we control for grades, and so controlling for grades for both the credit hours and controlling for grades in general education gains, this would be the correlation between credit hours and gains. So same thing here, you know, so in model 3, let's just take this one for example, this would be the correlation between quality of effort in the library and general education gains after both measures have been adjusted for differences on each of the covariates or each of the independent variables in the model. Sometimes in regression we refer to the independent variables as covariates, control variables, predictor variables, independent variables. So sometimes I use them interchangeably, so forgive me for that. The part correlation here, this is the correlation between the independent variable and the outcome when only the independent variable has been adjusted for the other independent variables. So you can see it's slightly different. So in the part correlation, you might see it called, I think Tabach and Bell call it a semi-partial correlation. it's the outcome isn't adjusted, the dependent variable isn't adjusted, but the independent variables are adjusted for differences on the other independent variables in the model. Tabachnik and Fidel in their book argue that if you're looking to sort of maybe like rank order the, which variable is most important in explaining variation in the outcome, they argue to use the part correlation, or they call it the semi-partial correlation. So they'd argue to use this column. You'll also see people also use the betas for that. Most of the time you come to similar conclusions either way, but you can see that sometimes they might be different. Like you can see the beta weight for learning is a lot different than the semi-partial correlation for it is. So basically all three of these correlations, these three correlations and beta right here, are all trying to get at this idea of the strength of relationship between that independent variable and the dependent variable, and they're all doing it in a slightly different way. The beta is converting both the independent variable and the dependent variable into z-scores and correlating them and basically put them into a regression analysis. Zero order is just regular Pearson. Partial is adjusting both the independent and dependent variable for the other independent variables. And then part is just adjusting your independent variables, but not the dependent variable. And then, yeah, there's just a clinarity diagnostics table, which again, you can ignore unless you have problems with multiclinearity. So that's my quick walkthrough of both a standard multiple regression and block entry regression. If you have any questions, please post them in the message board or email me. I'm always available to help. Thank you.